node. So for the root, I add a children, which is $1. We go.
So anyhow, if the length is not 0, then also we need to add the dollar, right?
Yes, I'm coming to that. This was just like, so when I was writing code, like I was literally like my thought process of, I don't know how this whole thing is going to work. Let's just take one example, that if you pass nothing. If you pass nothing, then what we should do? We should have a length is equal to 0 and then put this over there. Then I realized, okay, now next what we need to do? Next we got passed ABA, right? Now what I need to do is I need to add a dollar to it. So I will say string, I don't know, SG value is equal to SG value plus a dollar sign. Right? So add a dollar to it. Now, actually I took a string, but let's say that is okay. And then what I have to do is, now I have to create all the substrings for that. So how do I create a substrings? I will go from here to here, first substring, second substring, and stuff like that, right? So I will write a for loop. So for integer I is equal to 0, I is less than s value dot length
minus 1
I plus plus
and less than here.
Okay, and then what did I do?
Then for each
Yeah, string ser to add is equal to sg value dot substring, and I take a substring from
0
length minus I comma I plus 1. I plus 1 is the length. So you take a substring length plus I, so I'll get the entire length. First time it will be the entire length plus a minus I, which is 0.
Yeah.
So I'll start from here. Right. So I'll get one length. So this will give me, first time it will give me $, second time it will give me $, third time it will give me $, and I'll continue doing that till I reach this price.
First time.
Right? So this is how I'm creating all the suffixes. So I create the suffixes and then I call the function add to string. str to add to string is a similar function as the tries add to string. In tries node, we will continue to find a node and then continue adding that. So this is exactly similar to the tries. That's why I did the tries first, and now I'm doing this. So yes. So that was the only thing that is different in the tries and this is that when you are adding a value, you are just adding a for loop over here, creating substrings, and then adding all those substrings to a try. Right? That's all there is. Okay. But the destructor, I'm not going to write the destructor. Destructor is just calling a delete node. Delete node will call delete on all its children, and then it will delete itself. Find node is also similar to tries find node. That is exactly the same code. Okay. Is substring. So if we want to find a substring in this, what we need to do is, let's say AAB. We have to find AAB. Right? We'll check if AAB is a substring of this thing. What we'll do is we'll go to the node, find A, and B. If we find it, we'll return yes. If we don't find it, we'll return false. So the code for that is extremely simple. Code for that is a suffix node star current is equal to root, and this is Boolean, and this is substring. So Boolean is substring, string value. Okay. Then what we do is for integer I is equal to 0, I is less than sc value dot length I plus plus. We'll say a suffix. My handwriting is becoming worse. I know. A suffix node star child is equal to current. Find node. Sorry. Find node current, comma
I
suffix string at I. So I'll find the substring at I, and then we'll check if child
equal to
is equal to null,
then
which means that we did not find it. So we'll return false. Okay. Otherwise, if
keep
we
doing it, and at the end return true.
if we return at the end, we return true. Simple. Did we understand this? Yes? No? Swati? Yeah. Is substring. Okay. Rest everything is the same. I have not actually implemented the is. Let me see if I implemented the number of times. Number of times. Number of times that it appears. No, I actually have not implemented that. Let me go to the. I'll do now I'll convert this into a suffix tree, and then we'll go do that, and then we'll come to that. I actually did not implement that. Let's try to do the suffix tree first.
Okay.
So if you notice in this case, there's too many nodes which are getting created. There's too many nodes which are getting created. We can actually optimize it. So what we can do is, till the time this is, let's convert this and reduce this. So in reducing this, what we'll do is we'll go till it branches or it hits $1. So we'll go continuously go till it branches or it hits $1. If it branches at that point, okay. So this So according to
Her Highness, no.
Her Highness did not solve this. She did not do this. Let's see. So this was the suffix tree that will be happening for this try.
Camera will not cover you.
That's okay. We will convert this into this, and we'll compare if the logic is right or not. A dollar, B a dollar, and
Then AB a dollar.
A and dollar, AB a, and then
from
A and dollar, and then B a dollar, A B a dollar. Okay.
So what would be the complexity if you are using size?
Complexity is for
Finding a substring.
so basically finding a substring, the complexity creating will take time, but finding a complexity is order of n because you are just going through that tree. So substring, but creating actually will become n square because you are creating substring for every single time. So n square, and then you have to go through this. I think it will be n cube. I don't know.
Yes.
I don't know. I think it will be n cube
Yeah.
for creating. But for for the
Finding
its order of entry. Okay, so what did we decide? We decide like first thing is if dollar comes, we'll just make a dollar. Okay. Next, what is there is we have a dollar. We have a
dollar.
So the next thing is we have a, but we are branching at a. So we'll make a as a separate node. Okay. And then after that, a dollar comes on a, so we'll put a dollar over there.
So don't you think it should be $8 or is it?
We'll optimize.
Okay.
Okay. That's okay. Yeah. So a and then dollar, and the next was ABA. Right? It's not branching anywhere, so we'll create ABA and dollar. So next, what we will make is ABA and dollar. So we covered this part. Next will be ABA, and here it is branching. So we will write
BA dollar.
BA, and then there is a dollar. BA, and then there is a dollar.
Then ABA dollar under that BA.
And then after BA, there is ABA and dollar. So after BA, there is ABA and dollar. Okay. So this part is done. Let's go to B.
BA.
So after that, BA, it is branching over here. So we will write BA and then a dollar. BA and then a dollar. After that, it is
ABA dollar.
A and then a dollar. ABA and a dollar. Okay. See if that is right. So dollar and then A and dollar. BA dollar. ABA dollar. ABA dollar. Good.
Yeah.
BA
Perfect.
dollar. Everything is there. Yeah. So in this case, if you see the number of nodes over here were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it's 21 nodes over here. Number of nodes over here is 1, 2, 3, 4, 5, 6, 7, 7. If we actually take the dollar and add dollars over here, it's like 7 things, right? So we actually reduce a lot. We reduce this into like, so if somebody asks you a question on suffix tree, this is my recommendation. Tell them explaining suffix tree will take a longer time. I will explain you the suffix try, and then I'll convert it to a suffix tree. So you will explain the suffix try. You will say that okay, this is how the try will work, and then you will say, now I will convert it to a suffix try. So by that time you do that, it will actually take like 1 hour. So if somebody asks you this in an interview, try with the suffix try first. That is easier to understand and implement, and then go into this. Then go into this, and then say that okay, this is what you can do. Now if you think about it, let's say this is a smaller string, right? ABA. But if the string becomes bigger, right? These things will start becoming bigger, right? So what we can do is we can actually optimize this, saying that we get the index.
One question, sorry.
Yes.
So I know, we did the tries first, and then based upon, if it has a dollar, then you kind of convert this.
Yes.
But let's say if you are given a string, and if you are directly trying to convert it to a suffix tree.
I have the code.
How would you come up with this?
Come up with this. So what you will do is you will say, let me write. That is the code I was
It's
writing.
very easy.
No.
You can create the suffix strings and you can write very easy.
I will
Start from here, not from the back. From the first.
So we'll
It
do
will
the
be
same
formed.
thing. We'll do the same thing like this. So we'll first create a root. Then we'll actually, if nothing length is 0, we'll do that. Then we'll add a dollar. Then what we will do is we will find the substring, right? And then we'll call the add to string. So the add string is changing over here. So we will find the first children. So we'll find the first children. So we'll find, okay, let's say we have to, let's start from the beginning. Let's start from the beginning and implement this. So dollar A dollar
B a dollar,
B a dollar
A B a dollar,
A B a dollar
A B a dollar,
A B a dollar
B A B dollar,
B
A B A dollar,
a dollar
right? A B A dollar.
A B a dollar. Okay. Let's just. So
First
root, we created a root.
Yeah.
Next, what we created is created a dollar.
Now dollar is added.
Dollar is added. Now a dollar comes. We will check if a dollar
Exists.
exists. We'll check for all the nodes. Check if a dollar exists in there. Nothing exists, so we'll create a. Let's say a dollar.
Yeah.
Create a dollar. Okay.
Yeah.
Next, we'll check
B a
BA comes. So for all this nodes,
That's
so
right.
current, we make current is equal to this. Check all the nodes. We'll check if BA dollar is a
Start with zero.
is a child. It is not. So we'll create BA dollar. Okay. ABA dollar. So
We can
we
say-
what we do is we actually take the dollar out, right? Because a so then what we do is
we find the prefix of it.
we go one second. So what was ABA dollar. So we'll go with everything and then check